Okay, in this video, I'm going to show you how to use mactime along with another utility from SleuthKit to create a behavioral timeline for a DD file. So just to show you where to find SleuthKit, we can go to sleuthkit.org, and this has a wiki on it which has a really good display of all the information related to SleuthKit and how to use it. And so you can download it from there, but the easiest way to do this is just to use aptitude, sudo aptitude install SleuthKit. And it does everything for you. And it's installed. So we're not going to go too deeply into the SleuthKit because that's for the advanced forensics course, but essentially what it is, it's an open source toolkit that provides the same capability as a lot of forensic tool suites to do to conduct a lot of the forensics examination for various types of file systems. So now you can read up more about that on the wiki if you need more information about that. But we will be using mactime, and we'll see where these are, and FLS. And FLS will take a DD file and then dump the file and directory names into a disk image, and along with information about the modified accesses and created times. And then what mactime does is it maps that to a chronologically sorted list of files and directories. So what we need though is, let me go back here, and we need to download a DD. And so I've downloaded an example file here to my downloads directory. Let's make a directory here, mactimes, if I can spell, and then we'll download to mactimes.evidence, and we'll unzip this. And this was 20 megabytes zipped. Okay, so it is about a gigabyte. So we need to run two different commands. The first is called FLS, as I said, and that just takes a DD and outputs the mactimes, not in chronological order. That's what the utility mactime does. So we're going to run FLS for recursive and to get that, and we'll start at the root directory for this DD, and what's it called, mactimes.dd, and then we're going to out that to something called body.txt. Okay, so what do we have? So we have our body.txt. Let's take a look at that. Oh boy, see, you can't read that. So essentially what that does is that outputs the raw information to the file. Now we need to organize it somehow, and we do that with mactime. So that was really easy on a 1 gigabyte DD. Okay, so now we can run mactime, the -B for the body text, and so this is going to go in and strip everything out of from the FLS and chronologically order everything. Okay, that was very quick, and we use a wide display on this. So let me see if I can make this bigger, because this ends up being a very wide file and less. And there we go. So, and notice this is still wrapping over here. I hate that. There we go. See if I can make this wide enough there. Okay, you have some interesting stuff in here. Notice Wednesday, December 31st, 1969 at 1900 hours. That's really interesting. I'm not going to tell you why that's there. In fact, I think I've already explained this. I can't remember, but do you remember what the Unix epoch was? Unix epoch was the really the birth date of Unix, so everything is actually measured date and time stamps from the Unix epoch. And so what this is saying is this actually started on the Unix epoch for these files. So that's probably not correct. Okay, let me go down here to something that's actually correct. Notice all, let me go back up to the top. It makes sense that a lot of this would be C's. So let me go over this. So everything under Wednesday, December 31st, 1969 at 1900 hours. This would be all the files that were created here. Notice that this is going to be the file size in here. And notice that you have three little columns here. The three dots indicate that this should be an M. If it was modified, this would be an A. If it was accessed, this means it's changed. And this should be delete. Notice it says this is a directory. And look at the permissions here. Read, write, execute, read, write, execute, read, write, execute. It does not show an owner. And this is the inode number. And then the location of the file and the file name. Okay, so if we keep scrolling down, hitting the space bar, keep going. Notice a lot of these are changed, which we're assuming that's when they were created. That was their birth date. Okay, now we get to some modified files. And so Wednesday, November 8, 2006 at 1638, notice that 1, 2, 3, 4 files were modified, and these are the names of the files. Let me go to the bottom and work my way up. And so I'm trying to remember what I had on this example, but it looks like that I had installed Thunderbird or copied Thunderbird over to a DD. Or perhaps I copied over some web browser information, or everything in my home directory rather. But you can see that this puts everything in chronological order. So for an assignment, I would copy over and modify things, so there would be a lot more interesting than this. This is just as an example, just to show you how mactime is formatted. I don't know if you can see this. If we go over here, and you see, notice the deleted. Notice all the way over here. Notice all these deleted files. As it turns out, it's very easy to recover these deleted files if they're not overwritten using the sleuth kit. So I might have you do that as well, but just for this simple illustration, I wanted to show you how mactimes works. So this gives you a really detailed analysis of modified access and created times for Linux, but it also works for NTFS. And because SleuthKit works with NTFS, it works with all different types of file systems. Okay, so that's the end of this very quick lecture. So you should go out and download SleuthKit, and you can create your own DDs. We've already done that in class. Copy some things over to the to your DD once you mount it, and and then unmount it, and then run FLS, then mactime on it, and see what you get.